Those of you that are interested in legal careers will find that this section is very applicable to your future pursuits. Any good crime show nowadays shows that DNA evidence is collected at the crime scene. Suspects of crimes are often required to give DNA samples also. These DNA samples are used to create DNA profiles. We make DNA profiles of suspects and at the crime scene, and then try to find a match. In order to make a DNA profile, the first step is collecting the DNA sample. This could be a cheek swab or a hair sample or any other fluids that could be found at a crime scene. Usually these samples only have a little bit of DNA, and so the next step is making copies. Instead of using the recombination effect, we usually use a process called PCR. Once there are enough copies, the DNA samples are compared visually using gel electrophoresis. Those are those little lines here on the gel, representing the DNA profile. So the lines represent genes. Can you tell from the image? Here's the crime scene, and these are the two suspects. Which suspect is guilty based on their DNA profile matching the crime scene? To make a DNA profile, you need to have a lot of DNA. The sample taken from a cheek swab or a crime scene is typically not enough. So the DNA samples are put through a process called PCR, which stands for polymerase chain reaction, and it can make billions of copies. So it uses DNA replication to make copies of the DNA samples. This is very, very quick and efficient because it doubles the amount of DNA each time it's done. So if you start with one DNA strand, right, like here we've got one, it goes through one round and then you end up with two. And then every time we double it. So then it would be 4, and then 8, and then 16, 32, 64, and then in just 7 rounds you would have 128 DNA strands. So each round only takes a few minutes, and in a couple of hours you can make billions of copies of DNA. Once the DNA has been copied, it needs to be inspected to see if it matches the crime scene. The process of gel electrophoresis separates out all of the DNA strands by size and results in a striping or banding pattern that's unique to each individual. So this is what it actually looks like. Those stripes actually fluoresce, and then you can match across the different samples. So what happens is after we've copied the DNA, the samples are put into holes called wells, and the gel has an electrical current moving through it. So the DNA has a negative charge, and so it moves towards the positive electrode. And as you might imagine, the small pieces of DNA are going to move through the gel easier, so they're going to move faster. And large pieces of DNA are going to move through the gel slower, and so they're going to end up closer to the gel at the end. At the end of the process, some forensic scientist can determine if the DNA from the crime scene matches any of the DNA taken from the suspects by looking at the banding patterns that are left on the gel. Another type of DNA profile that can be made from markers called short tandem repeats, or STRs. Much like the previous method using gel electrophoresis, STR sequences are compared between a crime scene sample and the suspects to find a match. DNA profiling was introduced to forensics in 1986 and is used regularly in adjudicating cases. One such was the O.J. Simpson trials, which implicated O.J. Simpson in a murder case in 1995. And it was actually shown that the DNA evidence of the blood that was found in his car matched the murder victim. However, the jury found that it was not enough evidence and he was found not guilty. So you can imagine that before DNA evidence was available, people might have been found guilty of a crime they actually did not commit. So the Innocence Project was started in 1989 and has used DNA technology to release over 340 convicted criminals who were wrongly accused or imprisoned. 17 of those were people on death row. One of those people was Earl Washington. So Earl Washington was sentenced to death for a rape and murder and lived for 16 years on death row. When the DNA was sampled, it showed that Earl's DNA did not match the DNA found at the crime scene, so he was actually innocent. The person who did match was already convicted for a different crime, and because his DNA sample had been put into the system, it was able to match with the victims. So DNA profiling is used for a lot of other reasons as well. One of them is finding remains after some kind of disaster. So, for example, more than half of the people who died in the World Trade Centers on September 11th were identified based on DNA samples that were taken from the disaster site and then compared to DNA samples that their loved ones had or to closely related individuals.